Hello, welcome to Choreographer demonstration. This demonstration, I will show it's possible to firstly define, then deploy and execute basic graph operation, BGOs on the computing continuum environment. For the simplicity, I just selected one node of computing continuum. It is fully based on Kubernetes. As you can see here, this node is fully ready and controlled plane of one cluster. And there are different types of services and node in this different types of services and pods in this node. For instance, different types of namespaces are defined here for the monitoring, for the serverless provisioning, also for workflow processing. The important one is OpenFaaS as open source function as a service for serverless provisioning. So in this environment, we firstly need, as a developer, we need to define our code and upload our code somewhere. For instance, in Docker registry like Docker Hub. As you can see, I defined all BGO basic graph operation described on the Docker Hub. Started from RDF load to concept filter, collaboration graph extraction, network preparation, network determination, and visualization, and then upload into the server, and then deploy that. Let me just show how it's possible to deploy such services here. There are two possibilities. One of that is based on command line. As you can see, I deployed this RDF load YAML here. I will show what is that YAML. It is the property of the basic graph operation here. So by just clicking, you can see it would be successful if everything defined well. But maybe the question is here, what is this YAML file? This YAML file is the description of the BGO, the uploaded one in the Docker Docker registry. So let's open it here. You can define what is the implementation, programming language, where is the Docker registry, and what is the address for just running execution. So by providing that, everything would be based on serverless. You deploy that and it would be ready for the execution. So for saving time, I just deployed all basic graph operation here. As you can see, all of them are listed. There are one replica for each BGOs. This replica could be a scale up and a scale down based on the requirement. So it is not the worry of the user, developer, but it is based on the backend services. And the number of invocation are shown here as well. So before jumping into the front-end services, let me just show some parts of OpenFaaS. As you can see, all defined BGOs are also defined as a pod in the Kubernetes environment, and all of them are in the running status. Also, if we see all function, you can see all of them are running as well, the function that I defined for BGOs. Let's show some UI here. So as you can see, the services of Kubernetes also shown the deployment status of all BGOs here, and the job, all of them are defined based on pod. So it should be shown here as well. And then the OpenFaaS environment, the UI of that, all described command line can be easy here. Developer just can to work with this UI environment and define their deploy their function here, define their YAML file here, and then invoke graphically via text file or JSON file or even HTTP request. And what will happen by the execution. For instance, here, as you can see, is deployed and is stand for execution. For the execution, one solution is such type of command line. So that means you invoke your function, for instance, that RDF load via the input provided in the TTL file, I mean that RDF file. And finally, if it would be successful, it shows such message based on the implementation. So it shows the number of triple in the RDF. And even here, I defined one invoke workflow shell, one solution for just chaining basic graph operation together. For defining our workflow by running that, you can see all invocation would be successful, and all of them, I mean, each function can be run, each basic graph operation can be run after another one. I mean, one function, one basic graph operation would trigger another, etc., etc. For just saving time, if we check how it's possible to define such type of workflow for different visuals, as you can see, I simply defined, the sequential one, the describe visual, also the workflow of them. So all of them could be possible to run here as well. So for instance, for RDF load, if you just copy and paste the TTL file, I mean the RDF here, you can see the result as well just by clicking the invocation tab. So for the monitoring purpose, we use Prometheus. Prometheus is just a tool for monitoring different monitoring metrics like performance, started from CPU usage, GPU usage, or memory, or any kind of performance parameters. Even here we use Kepler as sustainability in the easiest format, energy consumption, just for enriching our data as well. And for the visualization, I use Grafana to just send some queries to the Prometheus and then visualize the monitoring information in terms of the cluster, in terms of the Kubernetes node, also in terms of pod levels, also the OpenFast metrics. So here are just some result of the node level. You can see the CPU busy, the CPU usage, the RAM usage, also the swap memory. Here I completely disabled the swap memory for having a better Kubernetes, and then receiving different information and sending to the Graph-Massivizer, also Graph-Optimizer, to just make them inform about the solution, also about the usage. And here in the pod levels, in the Kubernetes levels, so till now we have all information from the pod, from the cluster, from the node, and we can inform other backend tools, Graph-Massivizer and Graph-Optimizer, and also make some better decision, appropriate, fun, and use for scheduling as well. Thanks for listening. I would be happy to answer.